my name is Ronak Parmar. I'm from WKL, which is White Knight Labs. My area of interest is in application and cloud security. I've been an OSWE, and specifically for cloud, I'm mainly into Azure and AWS. Additionally, I have a tool named Vajra, which is a cloud red team tool specifically for Azure, which has a lot of cloud attacking techniques, enumeration techniques and all, which we used in this Azure engagement. Additionally, I have been a speaker at multiple conferences like Black Hat, DEF CON, NullCon, RootCon, and yeah, MCTTP now. Before coming to this field, I used to be a DJ, a music producer, and I'm mainly from a commerce background. So no, I don't have any IT background. Like I studied IT while I was doing my commerce, and the world of coding and technology allowed me to be in this field, and I'm glad to today talk in this Germany conference. So thank you. Yeah.
Hi everyone, my name is Chirag Savla. Again, I work at White Knight Labs as a senior cloud security engineer. My area of interests are into Active Directory, Azure Cloud, and network pen testing and stuff. I have created few open source tools like Process Injection Toolkit, a tool named Calidus, which is like an POC tool that I released almost 4 years back, which uses Graph API for doing your C2 communications like Microsoft Teams, Outlook, OneNote, and stuff. I have also delivered multiple talks at multiple conferences, have trained people at Black Hat and many other international conferences as well. And I'm here at MCTTP to give you a walkthrough of how we actually initiated or did a red team assessment on an Azure cloud infrastructure for one of our clients, where we started from a low prev user and then we escalated to global admin, gain access to every other resource that they had in their tenant, right? So just a short disclaimer before we start our talk, that is there are few screenshots that we have created and added from our lab environment because we didn't want it to showcase certain things that is basically the client information. And even we are not going to go into the nitty-gritties of specific techniques that we are going to discuss during the talk, right?
So yeah, this is the whole attack chain, a real-life attack chain, which we did in one of our Azure pen test. So in the red circle, you can see there's the point from which we actually started, and we ended up till here, which is a global admin, which we were able to compromise of one of the on-prem server from cloud. So in this talk, we are going to deliver you 4 different kill chains, how we were able to compromise different stuff by a reader user, like getting access to a DevOps, getting into on-prem servers, accessing a lot of subscriptions, and also the Intune. So we'll start with the first one, which is reader to owner over the subscriptions. So this client, which we were doing pen test, had a lot of resources. They were having more than 25 subscriptions within their Azure tenant. So let's assume there's a company name XYZ, and we were given 2 different users, one for Chirag, one for me, and that user had a basic reader role over the intra ID and all the subscriptions, which is like the root management. So we both divided our job of doing the enumeration, and the goal was from the client that what we can break from a reader role, and that's what we did. We break a lot of stuff. So we started with enumeration, very basic in enumerating like what are the resources which a client is being using, all the users, service principals, applications, external applications, all the stuff that we can enumerate. So while enumerating, we found some of the juicy resources, or you can say juicy resources, which is very useful as a reader user. Why? Because resources like automation accounts, logic apps, and deployment templates, these are the resources which allows a reader user, a basic reader user, to read the source code. For example, automation accounts has a lot of runbooks, which are typically your scripts, and these scripts might have hard-coded credentials. Additionally, logic apps also has hard-coded credentials because they have to automate a lot of stuff. So within 3,000 plus resources, we found one resource, which is a logic app, and we found one service principal, which was typically hard-coded, And the use case of that service principal was just to read a credentials of an application. That's it, just a read. But the actual permission was application read-write. So even though the use case was just to read, the developer has given read-write permissions. So because of that, now we were able to use that service principal. So currently there are not much tools. So if you see in Azure, there are tools who can perform automated enumeration scanning, your permission scanning, all those stuff. But there are no tools which allows you to read the internal data of any resource. For example, let's say there are function apps. Let's say there are hundreds of function apps, and each function apps has more like 10 or 20 functions within those function apps. It's impossible for you to just go to each of the function apps and read each of the code, right? And there are no tools available there. But I have my own tool, which is Vajra, which allows me to scan in just one button, and it will go and scan all the source code. And by just doing a quick search of any keyword, I can find that keyword in those thousands of function apps. So this is one of those screenshots which we took. So here you can see we had a logic app, and within one of the logic app, one of the logic workflow, we found something similar like this. This is we developed from a lab, which is very similar what we did, which we got in the assessment. So here you can see there was a /users API call through this service principal. So they were just doing some read activity. So once we found this service principal, we quickly found out that this service principal has application.read-write all permissions, which is a shadow admin basically. So that means is if I use this service principal, I can actually add new client secrets in any service principal. So what if there's a service principal who has more higher privileges, let's say global admin privileges. So I can typically just go and add a new client secret. It's similar to what we do in IAM keys if you know about AWS. So it's very similar to what we have in AWS, but in Azure, we can have multiple keys. So as an admin, what we need to find out is there any other application who has more higher privileges? Ideally, yes, global admin, right? But we didn't found anyone, but we found one more application which again had similar permissions, which was an application administrator permissions, which again is a privileged role. So we again compromised that application as well. And now we have a very good amount of privileges to do within the intra ID, not the subscriptions, but within the intra ID. So again, we started our enumeration with another tool, which is road recon. So with this road recon, we found out that there was an enterprise app, and that enterprise app has a permission called group read-write.all, which means if I compromise this service principal by creating a new client secret and then log in to this client application, I have the permissions of group read-write-all, which means if I am able to find out any other group who has global admin permissions or any higher permissions, I can directly add my tester user within that group and I will get those permissions, right? So we did found some groups which has global admin permissions, but later on we also found out, and we added a client secret within this service principal and we got logged into this one. So so we found out that if there's a group who has privileged permissions like global admin, application admin, or any admin permissions, that group is called a privileged group. And only having a group read-write all permissions, I cannot add any user within that group because that group is now privileged. So we failed at that part, but we continued our enumeration again. So back to hunting. So this time, we started enumerating the subscription stuff. And while doing that, we figured out that there was one service principal who has a contributor role over a resource group. And that resource group has a lot of different resources like automation accounts, function apps, and all. So from which we have a different attack part, which we will cover in the further slides. So let's get back to hunting. So from here, we found out one group who was attached as an owner over the root management group. When I say root management, which means it contains all the subscriptions which the Azure tenant has. So and that is subscription, right? And it's not a privileged group. So I can use that previous application to add my user within this group, and from that, we become reader to owner over all these subscriptions. So we basically own the whole subscriptions of the Azure tenant, or we can say client's Azure tenant. So in this attack kill chain, we got a subscription, we got a logic app, we got a client secrets within this workflow. We use this client secret and compromise another application which had group read-write permissions. Using that, we added a group, we added our user to within this group, and we owned this subscription, which is 25, more than 25 subscriptions. So that was one kill chain. Let's go for another one.
So now we will discuss about additional attack path that was from reader, how we managed to get an access to the AAD Connect machine, and from that is like a hybrid identity system or a functionality that is available in Entra ID, right? And once you have an access to that particular machine, indeed you can escalate your privileges till global admin. So we are going to discuss that. And this, we also identified some new attack vectors which were not documented, like a lateral movement from cloud to on-prem using services like function app and app services. So we are going to discuss that as well, right? So now, while enumeration, right, we had an access. Initially, we started with reader role. Then we compromised some of the groups which had privileges on some of the resource groups, which were like contributor, owner privileges, and so and so. But then eventually we escalated and managed to get an owner privilege on all the subscription by modifying the root management group. That's when we started enumerating a lot of function apps. And one of the function app that was very interesting, because when we started enumerating that, we found it has something known as hybrid connection. Ideally, in app service and function app, hybrid connection is a feature which allows you to connect your cloud app service or function app to an on-prem resource or any other service hosted in any of the cloud environment. It could be AWS, Google, or any other cloud environment. So the configuration that we found was basically on a machine which is not present in the cloud environment, but it is present in the customer's on-prem environment. And the port that was enabled is 5986, which is ideally a PS remoting port over HTTPS. So we found that this seems like something interesting. There is no machine with that specific name in the cloud environment. So probably this machine is hosted somewhere else. Let's try to find out if we can use this connection and do something, right? So that is something that got triggered, and we started hunting what all things we can do. We found out this particular source code and that client function app, and this again gave us some hint that this function app is actually trying to connect to the machine over PS remoting. You can see that it is extracting the credentials from environment variables of the function app, and then at the end it is trying to execute some commands on the target machine using PS remoting over 59864 port. So then we started hunting for this. We built a similar lab environment in our own tenant just to test the entire attack vector. And then we found out that, okay, there is a way to compromise this. But we did not want it to add any new function to the function app so that we can leverage that instance. So what we did was we used something known as publish profile. So app service environments and function app has something known as publish profile, which has credentials which can be helpful for you guys to access the SCM portal of those applications. Maybe it is app service or function app. SCM portal is like an admin portal, admin management portal for those particular function apps. So what we did was we extracted the publish profile file. We managed to get credentials. These credentials are basically credentials which can allow you to use or authenticate to the SCM portal via basic auth. You can see that is endpoint, that is function app name.scm/Azure websites.net/basic auth. This is an endpoint which can allow you to use the credentials that you find in the publish method as MS deploy. So we use that credentials. And now here you can see that there is a screenshot which has the Kudo engine page where you can extract all the environment variables, application settings. You also have something known as debug console. Those are basically a PowerShell and CMD console which you can use to execute code directly which means now you can use PowerShell commandlets directly from this portal instead of creating a new function in that particular function app and performing those actions, right? So then we started understanding this complete entire process. We knew that there is a machine which is connected. We knew that they're using environment variables to extract the credentials. When we hunted for environment variables, we found out that they're actually using manage identity to access a keyword in the environment variable, which means now since we own or have access to the function app, we can actually access those environment variable directly and get the credentials in clear text. So then we use those PowerShell commandlets to gain access to that target machine. When we managed to gain access to a target machine, we saw that internally we started doing some enumeration. Okay, this screenshot again is from our lab environment. We did the enumeration. We found out that we have AAD Connect machine that is installed on one of the server, and the user credentials that we had managed to extract was a local admin across the entire server, right? Which is again a win for us. So what we did, we started compromising that AD Connect machine. So in the previous screenshot, we can see that we used nested PowerShell commands to access that machine that is AD Connect machine, and we managed to gain access to that target machine. So just to give you a brief about what is AD Connect, or now you can call it as Microsoft Entra ID Connect Sync. This is a feature which allows you to sync your on-prem user with Microsoft Cloud, right? And there are multiple mechanisms that you could use for your syncing purposes or building a hybrid identity. So I'll just give you some brief about AAD Connect. When you install AAD Connect, there are ideally two users that are created. First, MSOL_star. When I mean star, there is a random ID that is added there, right? This is a user account which has privileges to perform DCSync, because this user account has to sync all the hash if you're using password hash synchronization method to sync on your Entra ID, that is your Azure cloud environment, right? Then there is another user account that is also created, which is in the cloud environment, that is sync_star. Again, a random ID or value is added there. This user account has a privilege known as directory synchronization privileges. Now, this user or this privileges in Entra ID could allow you to perform multiple actions like resetting a user credentials, which is a sync user credentials, adding credentials to service principal, and many other things. So the best part of this is the credentials are stored in a SQL instance installed on the same server, or probably if you have modified it, it would be stored in some other service, which is again encrypted using some DP API mechanism, which can easily be decrypted, and you can get clear text credentials for those particular user account. But we had some challenges here. We found out that the client is using one of the ADR. I'm not going to name that. So we had a task to bypass that ADR solution and get our code executed. So what we did, we started using the raw code snippet from Adam Chester, that is Azure AD_decrypt_MSOL_v2. Note that this code snippet only allows you to extract the credentials of MSOL account, but what about sync account? But there is another good tool named AAD internals. I hope if you are using Azure, you would have heard about that. We use that code, we gone through that code, we found out that what is the implementation done to decrypt the sync user credentials. Then what we did, we customized this entire script to first extract the credentials of our MSOL account. Then we modified a script in a way which will actually get deployed. We splitted the script into multiple parts, wrote that script on the disk, on the client machine, and then we extracted or executed one by one code of that particular script, which indeed allowed us to bypass the EDR, and at the end, you can see there were like multiple executions that we did, and at the end, we managed to extract the credentials because it was writing an output file to a text file, and here we managed to get the credentials of a sync user, and then we authenticated as a sync user on the cloud portal. Note that since we had the sync user privileges, we also found that the client has a global admin user, which is sync from on-prem to cloud, right? But we cannot reset the credentials of cloud-only users, but we can still reset the credentials of sync users. But client did not give us a permission to reset the credentials because that user was used for some other activities, some other automation, so we restricted ourselves. But indeed, by doing this activity, we were almost like a global admin on the client environment. So you can see that from a reader role, that is from the attacker path, we eventually ended up compromising a global admin, right? So this was like a second attack path. Now the third attack path is all about Intune, how we managed to compromise Intune.
You can hear me? Yeah. So let's talk about reader to Intune. So you remember I told you that we found an app which has a contributor role over a resource group. So we'll continue from there. So since we found, initially we found an application which has application read-write permissions, and by enumerating with the tool Vajra, we found another group, which found another application which has contributor role over resource group, and that resource group has multiple automation accounts. And since we have contributor roles, we can do some stuff like reading credentials. So in automation account, there's something called as credentials which can be stored but cannot be read. Just like creating a password. You can create a password, but you cannot read the password. So those value of those credentials can only be read by the runbooks of the automation accounts, the scripts which are going to get executed. So since we were the contributor, we had the permissions to create runbooks. So we quickly just created this script which had all the names of the credentials, and by just executing those runbooks, we were able to this was the command which we used. So by using the import AZ automation runbook, so this is the Azure PowerShell command which we used because we had service principal, we didn't have username and password, right? So we cannot log into automation to Azure portal. So we have to leverage Azure PowerShell modules. So by using those commands, we created a new runbook and started this script. And in the job output, we were able to list all the credentials, and these credentials contains username and password of a lot of internal applications like application proxy. So application proxy again is some applications running within the on-prem server, and it's actually having an external URL which is redirecting the internal application publicly, and those internal application has the credentials in here. Additionally, we found one credentials which was actually an Intune admin, and when we try to log in, it asks us to set up the MFA. So like MFA was not yet set up, we got a question that would you like to set up the MFA? So once we tried to do that, we had an issue. We were not able to configure the MFA due to conditional access policy, and the policy was something like you need to have an hybrid identity, like hybrid join machines, and some other compliance stuff needs to be marked. Only then you would be able to do the MFA. So, and also we had an issue with the Intune policy as well. So due to some Intune policies, we were again not able to perform the MFA setup. I think Chirag can say more about this one.
So what we saw was on the conditional access policy, the policy was that only an hybrid joint device could authenticate using these credentials, right? And the second policy was the device has to be compliant, right? And in the client environment, we also had an Intune policy that was configured that the device should be having XYZ settings, only then the device could be marked as compliant. Still, what we tried was, we tried to fake the device compliance. You can again use another great tool, that is AAD internals, to fake the compliance of the devices. So what we did is, we first requested an access token by using a device code authentication methods to register a dummy device on the target machine, right? Once we tried to register a dummy device on the target machine, we tried to fake the compliance again using the same AAD internals tool. But we were not able to fake the compliance because of the Intune policy. This was one of the failure attempt, you can see, to gain access to that particular Intune admin device. But again, if you have access as a reader user also on the client tenant, by default, you can also access the Intune portal. Now, the best part here is, Intune portal, if you are using Mac devices, Linux devices and stuff, any scripts that you use to automate your task on those devices can be viewed in clear text. So now here you can see that we can actually see one of the script which was used to add a local administrator on the Mac devices. And we managed to get the admin credentials of all those devices because this is the credentials here were present that were in clear text. Second thing that we found was the funniest part, that is a license key to the EDR. Right, so now we can use this license key and install the EDR. We can have the same config in our own test environment, test out all the policies and even find out bypasses in the environment, which could be like an EDR bypass or considered as an EDR bypass. Note that there are also PowerShell scripts that can be used on your Windows machine, but you need explicit access to download that. Those cannot be read like the way we can see it here. But if you have explicit access to read those PowerShell script, you can again dump those PowerShell script and you can find some privileged credentials or user credentials that could be really helpful. So this is the third kill chain where we ideally managed to gain an access to an user which was almost like an Intune admin. If we would have managed to get an access to this particular user, indeed we would have compromised entire on-prem infrastructure or on-prem environment, because Intune also has the capabilities of executing code on those machines, right? So this could have been like a major win for us because all the on-prem environments could be managed or controlled by us. So now then, the fourth kill chain that we are going to discuss is about Azure DevOps, right? So initially, when we started hunting, when we managed to access all these resources and everything, we still did not find any access to the Azure DevOps environment. So because the Azure DevOps environment, the IAM policies and all the access control works a bit different, you may or may not have direct access as a reader, user to any of this DevOps environment, right? So what we started hunting for specific values like PAT tokens, that is like personal access tokens, started hunting for any credentials that we have missed that could allow us to give access to our DevOps, but we did not find any of those stuff during the hunting process. So then we requested a client, can we get a reader access on your DevOps repos or the DevOps environment? Client gave us a reader access on the DevOps environment. And then we started hunting for use cases which could allow us to escalate our privileges and gain access to all the repos or whatever the repos that are present. Luckily, we identified that there is a contributor role, which is in a contributor role, there was an Azure AD group that was assigned, right? Which means we have already compromised one of the service principal, which had group read-write.all privilege, which means now as an attacker, we can add our own user to that particular group, gain access as a contributor on the DevOps environment. So that's what we did. We managed to gain access to that group by adding our own user. In that group, we had 2 users, which indeed allowed us to add, modify every repo that was present in that particular DevOps environment, right? Because a contributor has that privileges. We found multiple hard-coded credentials, PAT, that is personal access token, database connection strings. We found out credentials even for third-party services, third-party email services also like Gmail and all those. That is basically all those credentials were working credentials. We found few of these Gmail credentials which had MFA, but most of the other credentials were open. We also actually found out one of the access to one of the financial application that the client was using because they were hard-coded. Again, the credentials were hard-coded in one of the repos. So this indeed allowed us to get an access to a lot of hard-coded credentials. Now we'll discuss about one of the failed attempts that we actually tried to gain access to a global admin.
So yeah, this failed attempt is based on the Cloud Shell, which Azure has. So in Azure Cloud Shell, it uses a storage account. A storage account, again, is a different service. So this Cloud Shell uses storage account to store its .img file, which, to mount all its file within the storage account. So since we were the owner of all the subscriptions, and again, there were a lot of storage accounts which uses Cloud Shell, but we need to figure out which user is actually actively using a Cloud Shell, because only then we would be able to compromise those users. So what we did is we went through the logs and we just tried to see if there's any log through which we could figure out which user is actively using the Cloud Shell. So we found one user who was kind of using Cloud Shell in every 1 week or 10 days, something like that. So, and since the assessment was about of 3 weeks, so we planned to target that specific user. So what we did is we directly navigated to this storage account. So any storage account which is using Cloud Shell usually starts with word CS, and the file share name also starts with CS. So CS is like Cloud Shell. So we went to that storage account and we downloaded the file share of that specific storage account, which is this one. So it ends with .img. And since this is a ext2 file system, so it only allows Linux-based systems to mount this file. So we downloaded this 5 GB of file and mounted this to our local system. And we found out these applications. So in there, again, Cloud Shell has PowerShell and Bash terminals. So what we did is we tried to modify 2 special files, which were like the startup files of the Linux and the PowerShell, or I can say Windows. So for the Linux, the file name was bash rc, and for the Microsoft like PowerShell, it's PowerShell _ profile.ps1. So we quickly just created these files and uploaded those files within the root folder of this img file. So the code which we wrote is this. So what we are doing here is trying to zip a folder which is .azure, and .azure is basically your file which contains all your refresh tokens and your access tokens whenever you try to log in with AZ login or connect AZ account. So .azure, which is A is small, it means that is for the Azure CLI, and if the A is capital, that's for the PowerShell module. So what you're doing is just trying to zip the whole folder, and we are uploading this folder to this specific IP where we have this upload.php file. So we are just trying to upload the whole zip folder to our attacker server. And similarly, for the PowerShell, again, we used invoke REST method, and we are uploading the whole folder. You can see .azure, which is now for the PowerShell. So we just uploaded this. So we modified these files. We unmount this whole img file and upload it back to the storage account. So by assuming then that whenever an admin or that specific user open up the Cloud Shell, doesn't matter Bash or PowerShell, because we have startup files for the both, automatically those specific codes, which are these, will get executed, and the whole Azure folder or zip file will get uploaded to our server. So if I just give you an overview, the attack methodology was that we'll download the Cloud Shell img files into our local systems, update it maliciously, and we'll assume that user will again open a Cloud Shell, and whenever he do, we might get that whole zip file, and we can just use that in a local system. But unfortunately, that user never opened up the Cloud Shell. I don't know why, but yeah, so this was a failed attempt, and that user was actually a global admin. So if he would have done that, we would never do that attack which we did for the cloud to on-prem stuff, because we directly have the global admin. But yeah, this was the failure attempt which we had in this whole pen test. And these are some of the reference links. Few of the attack kill chains, we had a blog as well. So first blog is on the pivoting from Microsoft Cloud to on-prem machines. So this one is how we pivoted from the function apps to the on-prem. And the second one is on abusing the logic apps. So this is a blog which we wrote on how we actually use logic apps to make it look like a function app and compromise it from the storage account. So if let's say you have a contributor role over a storage account, how you can use the storage account permissions to compromise the logic apps and get an RCE over that server. And we have another blog which is on the function apps again, but it's something like how you can again use a storage account to manipulate the package files of the function apps to get the access over the function apps and perform the on-prem to, cloud to on-prem activity. Yeah.
You're using compiled applications, right? Like your .NET or Java-based applications. If you try to deploy those applications using VS Code or any other tooling like Azure Visual Studio or anything like, they will get compiled. The source code will get compiled and will get uploaded as a DLL files or probably a compiled file for Java on this function apps. So even if in case if you manage to gain access to a function app which is again using hybrid connections, and if they're using compiled language like .NET or Java, you can go about doing a reversing, modifying that particular source code, re-uploading that particular zip file to that particular storage account, and you can still compromise the function app, and indeed which could allow you to gain access to the client environments. So that's all for our talk. Any questions that you guys have?